Good afternoon, everyone, and thank you for joining us for the 7th installment of the CxEnergy virtual experience. These webinars are presented by the ABC Commissioning Group, as well as its sister organizations, the Associated Air Balance Council and the Energy Management Association. I'm Sam Schwartz, and I'm a Member Engagement and Marketing Manager for ACG, AABC, and EMA. Since we were unable to meet in person this year at CxEnergy, we're hoping to bring you as much of the commissioning, energy management, and testing-related education as we can through a combination of live webinars like this one, as well as some additional pre-recorded sessions. Continuing the virtual experience today is signal-to-noise ratio. Can you see me now? With your speaker, Wayne Dunn of EW Dunn. Thank you again, everyone, for joining us. And with that, I'm going to hand it off to you, Wayne.
Good afternoon or morning. The focus of our presentation now will be to describe the relationship between the implementation, installation, and application of security systems, right? Identifying the security types and providing some industry references related specifically to security, just like the AABC Commissioning Group is your go-to organization for commissioning references, and ASHRAE may be your go-to organization for HVAC references. I'm going to identify references for you that apply specifically to security and reference documents. All of the documents that I show here are freely available on the internet through PDF, and for those who are allowed to download the presentation, they can obtain those documents. I'm going to categorize security goals and risks within a specific purview of security systems, and then demonstrate how to align commissioning to security system delivery. So what elements of commissioning and the commissioning process, as it's generally known, as it flows from OPR to BOD to commissioning specifications through to installation checks, factory witness testing perhaps, and field verification checks. How does that actually apply to security system delivery? You know, what is in the way of ongoing commissioning and post-occupancy operation? So security, when you talk about it, in its raw definition is a noun, and they call it the state of being free. In our buildings that we're looking at, what are we trying to be free from? Air quality risk, comfort, noise, lighting, external intrusion, internal disruption. I mean, these are all nice words that get around, you know, at worst case, somebody breaking into the building or somebody within the building causing significant disruption, as we have just seen at 2 of our naval installations, in one in Texas and one in Florida. Both were troubling occurrences. Both were related to external intrusion in Texas and internal disruption in Pensacola, Corpus Christi and Pensacola respectively. Business risk in terms of cyber, business interruption, contamination, those risks are dealt with in varying forms, and many of these things are not within the purview of this presentation. Within this presentation, I'm going to deal with commissioning as we're sort of used to doing it, as we're used to doing it on new construction, and then as we're used to doing it in ongoing systems. And with ongoing or existing systems, it's pretty much an assessment, countermeasure definition process, and execution. So we set our physical risk goals and establish what we're going to do to mitigate those risks. There is no perfect, this is for the people that are old enough to remember that we used to have duck and cover drills, where we would, upon fear of being attacked by a nuclear bomb, everybody would duck and cover under their desks. I guess so that we would, anyway. So security has evolved over the years. as you can well imagine. We've come a ways since duck and cover drills, but we still have, things that occur that are just nearly as useful as duck and cover drills. So let's talk about what is security and what is resilience. And I think Homeland Security and Major General Walsh provided me with what I believe is the best and briefest description of this. It is outlined in the Presidential Policy Directive number 21, right? And it basically defines security. And I know it's always bad to read through a slide, but in this case, it's worth doing, right? Define security as reducing the risk, right? So this is as absolute as thermal comfort. No two people are comfortable at the same temperature point. No measure of risk is ever thoroughly and 100% deferred. It is just mitigated or managed and handled as best it can. Just ask the NSA and Mr. Snowden, I think his name is. So infrastructure by means, physical means or defense cyber measures to intrusions, attacks, or the effects of natural or man-made disasters. So resilience is different from security. They're the same and different. So resilience is the ability to prepare for and adapt to changing conditions and withstand and rapidly recover from disruptions. Resilience includes the ability to withstand and recover from deliberate attacks, accidents, or naturally occurring threats or incidents. So let's think about that for a minute. Resilience and security are very much like signal and noise. And we're all used to this now that we all have cell phones. As a pilot, I've been used to this for years. This chart is literally the chart that we use in determining when we've got good radio communications. You may have heard the expression 5 by 5. So you'll note that there are 5 categories here. And those 5 categories go from fading to loud and from intermittent to clear. So you've probably also heard, I can hear you loud and clear. So your signal strength may be loud, but all you may be receiving, your noise clarity may be with interference or intermittent or distorted. What we commonly call with our internet communications now, tiling. The same is true of security and resilience, right? Security can be strong, but it may not be resilient. And there is a space fence in the Pacific Ocean and Kwajalein, on Kwajalein Atoll. And that space fence installation and that entire Air Force installation is very secure. However, it was installed without consideration to climate change. So it is not very resilient, as pretty soon portions of it are going to be underwater. So signal, loud, noise, clear. And how do we ensure that we have clarity in our decision-making process as we go from OPR through to final testing, so that we're not basically weak and distorted? So now think of, to just put this in sort of a final light, think of your cell phone. I mean, we've more than one had calls drop as they transition from cell tower to cell tower, or as something occurs within that system, and you'll hear them talk about a self-healing network. That's the ability of 2 good cell phone towers to make up for 1 weak cell phone tower, and how that signal strength is interacted with your phone and how to make those things better. Well, we're looking at the exact same thing with security systems. So access control and threat protection are 2 of the things that are in scope. When you're putting together your OPR, it's just as important to declare that which is not in scope. For example, screening. So screening and doing background investigations like what we do when we have a facility clearance level and we're establishing who is allowed to have top secret clearance in a given facility. That is a separate task. So once that task is executed and someone is in receipt of their badge, then our system will allow that person into the system. We're not responsible for determining whether or not that person gets a badge. It's very important that you say this in your OPR to ensure that you have identified that when someone comes along with an authorized badge and comes into the system, maybe after they have quit the company, you're not responsible for that person being able to effectively break into the security system. So what is the history of physical access control and threat protection? Is it a moat? Is it a portcullis? Is it a safe? So we look at the thresholds of the site, the building, and the room, just as they did literally centuries ago, only applying it to, with different technologies. Because even my Chevrolet Volt or my friend's shiny new Tesla won't float. So we have different ways to provide access to facilities. We've got different things that we're looking at monitoring, recording. We're running from some kind of central system. We may have a whole bunch of cameras. We may have this shot stopper system for detecting bullets being fired. Those are being used now in combination with cell phone monitoring systems to try to determine if a given cell phone is in the same area that a shot was fired. So this shot stopper has been through a few gyrations, but it's now starting to work a little bit better. So if we're responsible for commissioning a shot stopper system, and what you'll find is vendors of these types of systems don't want third-party commissioning. And it is worthwhile to have third-party commissioning for these types of systems. I know that the little fellow in the lower right-hand corner there, the Queen's Guards in England, they have third-party commissioning. It's typically called inspections, and they're pretty rigorous. So more items that are not in scope. So the monitoring and recording systems and validating that those systems are performing against with specific metrics are included. Cybersecurity is not in scope. So if somebody gives somebody their password and they break into this monitoring system, that's not in the scope of our commissioning. Intellectual property. If somebody steals your secret, your grandmother's recipe, then that's not in scope. Fire alarm and protection. Fire alarm and protection systems, or in other words, floodgates closing, they're not in the scope of security system commissioning, just an interaction with them. So there's some discussion about fire alarm and protection because the fire alarm protection may be in your commissioning scope, but it's not in your security system commissioning scope. So you have to address how fire alarm and protection is covered. But I would strongly recommend, just going back to that, I would strongly recommend that you treat all three of these things like independent scopes. So if you're involved in cybersecurity, if you're involved in intellectual property protection, if your systems are involved in some kind of network resiliency, outside of validating that the network is working and people can't hack into the network without a password, but you're not, but they've decided now you're going to be responsible for facility clearance levels, then you want to set that up as a separate scope because that is validated in a different way. One of the largest organizations that's involved in security is ASIS. They've got 35,000 members worldwide, 51 chapters. They're big. They have the largest conference on global security exchange conference in the world, which I guess will be virtual this year. I'm not sure, but that is the biggest organization, and you can Google them or gsx.org, and you'll be able to get additional information from them. The ANSI spec that they use here that I've referenced is available on the internet. And they used to be called the American Society of Industrial Security, and now they're just called ASIS. So they've switched to just the acronym. They have been around since 1955, so they're even older than me, which is hard to do. And they're in over 125 countries, and they have ANSI accredited standards similar to our commissioning standard. So it's a worthwhile point of reference for commissioning services. In addition, FEMA has published, and this has not been updated since December of 2003, and it is still good. It is downloadable from the internet. It is FEMA 427, right? And it's the design of commercial buildings to mitigate terrorist attacks. And even this little diagram on the top here shows the benefits. And I have other presentation slides that literally demonstrate how building a lower standoff. So it talks about standoff, it talks about drag, hemispherical shock wave, impact on the building, what actually occurs with reflected pressure, how that is managed in the facility, what you have to look at. And there is a difference between a bomb that was set off next to the building, up here where this arrow is, and a bomb that was set off on the lower level of a secure facility where the road was below. And the difference in the damage to these tall structures is significant. Unfortunately, it wasn't a drill, and there were fatalities in both incidences. However, there were much fewer fatalities when they had the security measures in place. So what are you looking at in business terms? You're looking at total protection cost, right? The cost of hardening, the cost of windows and walls, the cost of the frame, the cost of the land and perimeter protection, which is obviously higher in New York than it is in Idaho. And then you're looking at a classic risk mitigation curve structure, high to catastrophic, high to moderate, moderate to low. What is the risk? So it's a business decision here. There are other metrics that I'm going to touch on that relate to that business decision. And then this is a really good set of circles here. There's components of security, structural hardening, which is what they're talking about up here, operational protection, perimeter protection, surveillance, guards, intelligence, warning, threat definition, preemption, right? That's out of our purview, and deception, that's out of our purview. So let's understand what's in our scope and what's not in our scope. So here, we're looking at level of risk or risk analysis, right? So we identify and value the risk. We look at threat opportunity analysis, criticality and impact analysis, vulnerability and capability analysis. What is the likelihood of something happening, right? I call it my asteroid complex, right? I mean, no matter what I do for this facility, I will not be able to protect it if it gets hit by an asteroid, right? So, but that's also not very likely, right? What is the consequence of a given event? And we have to actually try to figure out, right? And there's a lot of statistical data available because unfortunately there's been a lot of security breaches over time in determining what that level of risk is. And it's good to understand this profile, even if you're not involved in security systems. I was brought into this because I've been involved. One of the things that I've been involved in my career are a lot of mission critical facilities. We use the exact same analysis. It's called failure modes, effects, and criticality analysis. What are the various failure modes? What are the various threats and opportunities, right? And what is the criticality of those failures, right? So failure modes, effects, so the failure mode and effect, and criticality analysis. What could go wrong? What is the failure mode? And how much do I care? That's your criticality analysis. I call it the what could go wrong and how much do I care report. So that is an element of risk management. It's something you're trying very hard to put numbers on. What are the odds? And how much money should I invest? Another document that's available that is a little more current in terms of its technology interface, but no more valuable than the FEMA document in terms of its physical security definitions, is the risk management process for federal facilities, commonly known as the ISC. So throughout my presentation here, and I'm going to talk about ISC, I'm talking about this Interagency Security Committee presentation. This is a flow chart here. So let's look at this flow chart for a second. The top here, it says facility security level and LOP, level of protection. Now you're looking at this chart here, it's literally like the failure modes, effects, and criticality analysis, or like the previous chart. So these charts have very similar metrics, and I mean flow, similar workflows and different metrics in terms of how they're actually applied. These documents, this FEMA document and this ISC document, are valuable downloads. So does this relate to commissioning, right? And let's look at that for a sec. So we come back here and we say, well, in the beginning, I'm going to identify my baseline level of protection. I'm going to establish what my risks are. I'm going to look at what my security profile is. I'm going to establish my OPR, right? I'm going to figure out what my countermeasures are going to be, right, with respect to security. And how am I going to do that? I'm going to do it literally like what's happening here, right? Pre-design phase, establish what the owner's program requirements are, review those owner's program requirements, start developing our basis design, establishing our metrics and our measures that we're going to take. Are we going to use a gate? Are we going to use a fence? Are we going to use a barricade? Are we going to use a vehicle interruption device? You know, what are the devices that we're going to use? What are the specs? How are we going to test it? Right? Think of it like your fire alarm system, right? We're going to verify that all the sprinkler heads work, right? By using the UL rating, the numbers, the tags, the manufacturing data. You know, maybe we even go to the sprinkler head manufacturer and conduct a few tests. We're not going to test the sprinkler heads by setting the building on fire. So we're not going to test the building, right? Some of these devices, like by flipping a car into the air. So we're gonna have to figure out what is the right measure and how does it stop. Now we know that it works because that's how that lady stopped that fellow that shot her. And thank goodness her bulletproof vest worked, and she had the wherewithal to hit the gate and stop the gate and stop him at the gate. And then together with her colleagues, they managed to stop him for the rest of time. So testing was done of that system, but they didn't test it with a car. Although in this case, the Corpus Christi case, it was tested with a car. What are we looking at here when we determine facility security level? We're looking at mission criticality, symbolism, facility population. Unfortunately, these are some of the things you have to think about, right? How many people, you know, could potentially be impacted, right? Threat to tenant agencies. So if you're the GSA and you have a building, and in that building is the Department of Transport, is the FAA, for example, and the FAA is de facto a tenant of the GSA, then the GSA has to consider this type of information as they establish what the security matrix is for that building, for the FAA. So physical security, right? Welcome to NORAD. You know, the Cheyenne Mountain Complex, it's made many a movie. War Games is one of them. You know, this is a door. I mean, you could see this door was built for more protection than just a half track. And then this is my house. No, it's not. But I mean, so when you get through NORAD, you actually don't end up in a 45-foot by 26-foot swimming pool and a hot tub down below. But this is what some people are doing with their homes. They are developing an entire underground operation for their house and allowing the top part to disappear. That is also true of military complex installations and other things. Basically, the top is a giveaway, and all the real security occurs underground. Not as easy to do in Florida, nor as easy to do here. This is another area where you've really got to think about what are you going to do for physical security. What are you going to do at the Washington Monument? Put it underground, or the Eiffel Tower, or this French bistro? which is now empty thanks to COVID, as is perhaps the Eiffel Tower and the Washington Monument. So what measures do we take in these facilities to protect them against some guy with a van? And how do we do that without, destroying the ability to see the Eiffel Tower? Well, actually, you can see some of that here. The pools and ponds and effects that are built around the facility that actually inhibit the possibility of any vehicular traffic. So you've got your security level determined and you understand what your facility security level is and what your risk is. And you've got for official use only measures put in place, your really cool ones, and as well as your ones everyone can see. And you've made your decisions. What is existing sufficient? Is it the highest achievable? And highest achievable, one of the things that determines that is money. Is it highest achievable with the budget you've been allocated? And then is that which is achievable acceptable? That's an important sentence. For those that are old school like me and writing notes, you want to write that one down. Is that which is achievable acceptable? Because you're revisiting your OPR and you want to direct that to your client. They go, yes, we're willing to make that compromise. You want to say, okay, let's modify the OPR, modify the testing protocols, modify things to recognize that we have decided that that which is achievable with the budget we have is acceptable. Otherwise, you're destined to have a failed test. So another thing you want to look at when you're building a facility is interim measures or construction security. If you're building a monument building and you've determined that that monument building has a high security level, a high baseline level of risk, and requires protection after it's built, odds are pretty good it's going to require some measure of protection while it's being built. That needs to be thought about. And always think about alternate locations. So this is another ANSI standard that is developed by ASIS. And it speaks to the site itself, right? Security management standards, physical access protection. I believe this is a purchase standard. Talks about the visitor, employee, lighting, cameras, gates, and landscaping. And there's also another guide that is freely available from GSA, the GSA Site Security Design Guide. So when you're looking at the GSA Site Security Design Guide, what exactly do you have in that document? The GSA Site Security Design Guide speaks to 6 zones. And those zones literally work from the outside in. They're going from neighborhood, zone 1, standoff perimeter around the building, zone 2. Zone 3 is site access and parking. Zone 4 is the site itself. Zone 5 is the building envelope. And zone 6 is management and building operations. So this site security design guide is literally, if you just Google that, GSA Site Security Design Guide, you can download it. So here's an overview or a graphic that shows you those same 6 zones. If you look at this carefully, you will see that the building is the center core of it, but and that's the thing we're used to working on. So in commissioning, we're used to having this conversation. Sometimes we come in after the fact. That can also happen with security. With security systems, they'll call you up and say, okay, we've got it built. We're now ready for you to commission it. You'll want to say, okay, well, you want to revisit this information, even if you're coming in after the fact just to test out something within the building. Because you want to understand how they've got themselves through from zone 1 through to zone 6, even if they're not using the GSA standard. Just basically say, okay, have you guys talked through these other things? Are there any tests that we're going to require? So basically what you're saying is that zone 1 through zone 5 is out of scope. And the only thing we're doing is testing the management and building operations of specific site devices, or maybe the gate on the parking lot, and that's it. So one item in zone 3 and a bunch of stuff inside the building. So what is involved? In the neighborhood, you want to coordinate, obviously, with other organizations or other agencies. Coordinate with local security operations. You've got to consider including right-of-way in the standoff perimeter. So you may be taking over a road, an existing road. And so that is going to involve some effort. Possibly close part of the street. You may have to install temporary barriers during construction. You obviously have to develop and coordinate personal safety programs. That is all recognized in the that is all recognized in the GSA guide. So zone 2 is a standoff perimeter. And the standoff perimeter is the standoff distance between structure and physical protection barrier. So in this case, you see a hardened fence. So what's not well understood is that these fences are very decorative, can be made very solid, but it's important. It's a complete conversation as to how solid you want it and how much you want to invest in that fence. And it gets right down to materials. Just like aircraft structures, you can go pretty solid with something that's pretty thin, although you better bring your wallet. Or you can give yourself a nice landscaping opportunity here with some concrete and use that as your mechanism to establish your setback, which is your unprotected distance from a building to another building or a curb or a vehicle. And then you can also look at a hardened barrier. And there's some innovative things that have been done. You'll remember that first slide that showed the vehicle roadway was underneath the people. So the band shown here would be lower down. And also it would prevent the inability of the building of making it to the building itself with some kind of sand or disruptive barrier. And finally, you secured standoff that can't stop you're seeing the application of the businesses that are made as it relates to facility. You might turn out that I've defeated myself here. Back here, you might have discovered that you cannot go to this street. You can't knock this street off. And now you're making a decision, what do I do? Down here, you may have to make a decision, I can't put in this curb height, right? The drainage plane won't allow for this landscaping to be at this elevation. This is inadequate. I need to lower this road, or we're going to have to move the facility to an alternate location. This is adequate because it turns out that this facility is not occupied by people that are typically at risk of threat protection. So those are the things. Now you're talking about site access and parking. People, it's where I am right now, it's 90 degrees outside. People want to be close to the building or they want to be in a parking garage. So there's a contradiction between forcing people to park at a distance in order to ensure no motor vehicle traffic can get too close to your building, and the comfort of the occupation of the people that are there, pedestrian circulation, first responder access. That's a big deal to try to consider. Somebody was unable to get first responder access to what would have been a relatively minor incident because of all of our security measures, and that's happened. Inside the security perimeter, you establish what your site amenities are. And again, you're looking at a lot of things, right? The federal planting, security pavilion, right? Ramp system. How do you manage that access? And then you get to the building envelope itself. And you'll see that you can use a lot with features, with stairs into the facility, start the facility occupancy on the second floor, right? Harden the building structure in the envelope, orient and mask to reduce explosive impact, like what's done here on the building on the left, right? And camera, sensor, and light placement. It's important to get the cameras basically now with today's technology, you can put in a lot more cameras and a lot more sensors, and it's important to make sure that you place them wisely and high enough and far away enough and with effective mechanisms for monitoring. All of these things come back to the commissioning process. We're looking at updating the commissioning plan, establishing that which it is that we could really do, reviewing the submittals from the equipment to make sure that that will pass your test. Remember, you're not reviewing them for design viability. You're reviewing the submittals for the test process that you're going to do, right? I've literally received submittals that said, don't test it the way you intend to test it. Yeah, right. This is, a sequencing and verification test, point validation test is not suitable for this as it's a network device. This camera is a smart camera. It tells you its address. It tells you where it's at. It tells you what it's doing. Don't input a false signal or a flash signal as it could lose its brains. So, and you say, well, that's what I was going to do to test it. I was going to have the equivalent of a flashbang grenade go off and see what happened to the camera. You say, well, you can only do that after it's commissioned. You can't do that while it's being commissioned because it has no resilience. So reviewing submittals is important, preparing for your functional performance test, verifying your construction checklists, walking through it. In security system commissioning, if you're fully involved from the perimeter zones through the interior, you better expect either on-site resources, depending on the size of the project throughout the course of construction, or a pretty regular level, a pretty strong regime of construction on-site presence. So zone 6 is management and operation, right? Flexible building programs, garden security operations, and you have to accept risk, as needed. And there's some things that you've got to think about in that regard. Verification measures, you want to document your countermeasures, right? Inventory and track during construction, run drills, and set up your red teams. And this is a movie from the 90s. You may not have all seen it. It was called Sneakers. And this group here was literally a red team. And their job was to try to go in and foil the existing systems. Look at your output measures. This is Appendix E from the ISC. So this is from the Intersecurity Agency Council Appendix E. Some of the stuff is FOU for official use only, but quite a bit of good information in terms of generic is out there. And the official stuff can be obtained as you need it, depending on the project you're at. So the hard questions you may have out there, there are hard answers available for them, but they're not published as readily, right? So now you've put in all these extra alarms, right? And you've put in all these extra cameras, and you found out that there was a sale on Ring cameras and you could get 5 for 1 or something, right? What happens? This is what can happen, right? That car alarm is so loud and nobody's anywhere in sight. Too bad at this point, I was sort of hoping for a thief. How many people respond to car alarms nowadays? Right? How many people, you hear a car alarm go off, do you even put your fork down? Right? Here's one that was even more surprising. In 2018, right, on Saturday morning, everybody in Hawaii woke up to the fact that there was a ballistic missile threat inbound. It was not a drill. And this is true. Like if you look at this sentence is 100% accurate. This was not a drill. It was not a drill. It was a mistake. So think about the opportunity that the people had that commissioned that system. These are all the different, this is I'm sure you'll be able to download the slide. This is a Siemens slide. This is them showing all the different things that can be done with technology, microgrids. This is all coming to facilities that you will be involved in. And it's good to understand what are the risks, rewards, benefits, and mechanisms to establish security within these systems. One of the things that they point out in that slide that's rather interesting is clock systems, something that we dealt with in launch vehicle infrastructure for decades, right? Is iRig style clock synchronization, which is haphazard at best in our industry, where the chiller clock or the switchgear clock is a local clock and it's not networked, and the building automation system clock has a different time on it. You can't do robust or worthwhile event analysis if the clocks aren't synchronized, right? You literally then, because what happens, and this happens a lot, is that you go back in to do your analysis as to what has gone wrong. And when you go in to do that analysis, somebody discovered that they forgot to, or they didn't, or the clocks weren't synchronized. And so to be helpful, they went ahead and synchronized them then. So now you don't know how much they were off at the time that you got your failure reports in. So you don't know if the failure reports are staggered, how they worked out. So here's how much you can trust your toys in your monitoring. So when you're looking at stuff, right, you've got to think about what exactly is going on inside of your monitoring center. Is there somebody trying to break in? Is everyone watching? Or are they really working hard at trying to figure out how to get around your security measures? So when it comes to zone 6, operation, that's an important thing. Well, here's the shot set for me. Here's the face recognition technology. Let the computer do the work. Don't rely on the person sleeping at his desk. Let the computer do the work. This is where you start getting into your occupancy and operations phase of commissioning or ongoing commissioning, where you're persistently running some kind of regime that's testing. So some of the best organizations that have gotten, as much as they've gotten bad press, is TSA. TSA has done an excellent job at figuring out how to establish a persistent way, and they've published this information. Some of it's for official use only, some of it's not. Some of the testing methods that they do, but the number of tests that they need to run, how often they need to run surprise tests, when do they need to bring in red teams, those types of things are publicly available. And some of the iterations. And that is a mechanism for ongoing commissioning, is to establish that. That is provided by a contracted support service. Another thing that's coming in that they're investigating is they're saying the building automation and control systems are a key point of vulnerability for these systems. That there's enough automation system and control infrastructure, lighting systems, HVAC systems, electrical power distribution systems, that those systems are a risk, that they are a potential Trojan horse to the facility. They have they could potentially be a backdoor to the IT. This is a double-edged sword here, because this has a big impact on cost. There's a lot of anticipation by those that provide these automation systems, and it's basically a really small little weasel clause that says, we anticipate that we will have guy goes, no, you won't. Now all of a sudden they're going, well, that's going to be a cost add. And you go, well, we didn't have a budget for that. Well, it was in my submittal. Systems has come to the attention of ASIS. It's well out there. They've got metrics associated with it, and they figure that it's going to be a really, really big business. There's a critical level checklist that's been developed and supported, right? And there's specific monitoring protocols that are being put in place, and establishing what the risk profile. Finally, talking on facial recognition. This is an example of facial recognition software. I don't know if anybody recognizes which one is Jim McGee, but it's a computer. And it's looking out there to immediately reject the guy in the middle wearing the hood. and and you can't tell which one's the Hulk. And to figure it out. But Jim McGee was smart. And he bought one of these facial that prevents computers from, so you don't know where Jim is. And that is the end of my presentation. I am okay. I had somebody else watching. Sorry, my apologies. I did not realize that that we were facing challenges.
Thank you, Wayne. It actually just happened at the very end, but throughout it, I can hear you pretty clearly.
Can you hear me now?
Ray is, yes, we can hear you.
So this is, you have good signal and good noise. I'd be 5 by 5, right? As you were listening to my presentation.
Well, thank you. I think Ray in the chat is calling for giving the last call and last chance for any questions that are coming through. Currently, we don't have any, so I think you did a great job of explaining everything, probably so clear that there are no questions. I am going to...
Sam, we do have a couple questions just came in.
Okay. Are there metrics for security projects similar to GBCI resilience rating systems like RELI and PEER, P-E-E-R?
Yes. Yeah, and actually the PEER metrics do cross over fairly well. The performance excellence and electrical renewal rating, the metrics associated with utility infrastructure have a lot more history than RELI, and so they're a good place to start.
Another incoming question. How do you see BACnet or BACnet Secure Connect improving BAS and security networks?
BACnet Secure Connect is a mechanism that is used to protect internal to BACnet itself, internal to devices using BACnet protocol. So the assumption is that there's been a breach into the system, and then you've got additional protective layers within the system itself. The IT resources are typically going from outside the system in through the into the system. So they're saying, so what you really need to do is you're going to be involved on using BACnet Secure Connect or the BAS and security network. You want to establish what your VPN strategy is going to be, because that's the only way you're going to get onto the building automation system. It's going to be through an approved VPN that has a clock to it. And on ultra secure facilities, you're going to get a monitored access. So you'll be required, and there may be a cost associated with that. There may be another contractor that's responsible for IT security within the facility. That contractor will grant you VPN access into this facility. You will then have your VPN window. You'll have to pay for them to monitor you while you're logged into the facility, and then you'll be executing your secure protocols, such as BACnet or BACnet Secure within that facility. In a lot of ways, BACnet Secure protects equipment from its internal.
Thanks, Wayne. Got a couple more questions coming in here. The next one is there a range of typical commissioning price for a security project?
Yes. There's no such thing really as a typical security project. And I'm not confident that it's something that could be established as a fixed range. But what you can look at is physical construction security verification will run 1 to 2% of the cost of the physical construction implementation itself. Technology installations will depend on what vendor measures are being put in place and whether or not you're just validating that the vendors have truly tested out their system or whether you're fully involved. And it will be more like the validation of utility system infrastructure, and it could be anywhere from 3 to 5% on a capital project. And I've seen it as much as 50%. So the range is kind of all over the place. It depends on what you're doing. Like if you're running a red team, you can expect your cost to go off the chart. I've seen systems where system validation and interrogation of the system and the lifecycle cost of the system in terms of maintaining it exceed the cost of the system easily.
Thanks, Wayne. We have one more question coming through. 4G and 5G internet services are required to support most of the technology you discussed. What do you see as the most viable mitigation strategies for loss of internet signal, loss of power?
Okay, that is actually not true. Very few of the systems that we operate are utilizing wireless integration. You know, if you're looking at mission critical infrastructure, you're not sticking a camera up on a Wi-Fi. Those will be background support systems. So power outage, signal interruption, signal intrusion are all part of your initial failure modes, effects, and criticality analysis. And then if you're looking to deploy wireless technologies and you're looking to rely on something longer range like 4G or short range but higher quality like 5G, then you're going to want to set up, and we've done it, but it's been a self-healing network. And so what you're saying is the infrastructure that you're putting in with respect to 4G and 5G networks and the wireless infrastructure that you're putting in is going to have to have an entire infrastructure associated with it that may exceed the cost of putting in wired devices. So it's an entire conversation of its own accord.
Okay, thank you, Wayne. That was actually the last question, so thank you so much for presenting. I just want to close things out by thanking everyone who joined us today, including our members across all 3 of our organizations. Please keep an eye out for an email with information regarding your learning units from the CxEnergy app. While in the app, we're also asking all participants to please evaluate this presentation. We hope to see you again next week for the final live webinar in the series titled ASHRAE 9.1, Commissioning Requirement Changes and Comparison to the International Energy Efficiency Code, taking place June 11th at 2 p.m. this same time next week. Enjoy the rest of your day, everyone, and thank you.